Okay, section 11.3, limits and continuity. Alright, our goal here is to determine whether a function is continuous at a number, to determine for what numbers a function is continuous. Now, for a function to be continuous at a, there has to be three conditions are satisfied. F has to be defined at a, that is, a is in the domain of f, so that f of a is a real number. The limit as x approaches a of f of x exists, the limit exists, and the limit as x approaches a of f of x equals f of a. So let's look at this one. Determine whether the following function is continuous at a. At 1. According to the definition, three conditions must be satisfied. First, the condition, the function is defined at a. So we plug in 1. We plug in 1 here. We get the answer 1/3 and it is defined at a. That's good. Second condition, the limit of f of x exists. So we say, okay, the limit as x approaches a 1 is the limit of the top and the limit of the bottom, which is 1 minus 2 is equal to -1. And 1 squared minus 1 is -3, which is 1/3. Using the properties limits, we see that this exists too. The function exists and the limit exists at that point as we go through. Okay, third, determine whether the function is continuous. According to the definition, three conditions must be satisfied. The limit of f of x if x approaches a has to equal f of a. And so, the limit of f of x was 1/3. The f of 1 is 1/3. Because these conditions are satisfied, we conclude that f is continuous at 1. So not too hard. Now, if f is a polynomial function, the limit as x approaches a of f of x is equal to f of a for any number a. A polynomial function is continuous on every number. Many functions are continuous at every number in their domain. Rational, exponential, logarithmic, sine, cosine, tangent, cotangent, secant, cosecant functions are continuous on every number in the respective domains. If we know, in other words, if we know a function is continuous, we assume it stays continuous as it goes through. I got the spinning wheel, so let's see if it's going to die or maybe not. If f is a polynomial function, the limit of f of x is approaching a for any number a. A polynomial function is continuous at every number. Many functions are continuous at every number in their domain. Rational, exponential, logarithmic, sine, cosine, and all these functions are continuous. Determine for what numbers, if any, the following function is discontinuous. Two x equals 0, x squared plus 1, 7 minus x, so on down the line. First, we determine whether the three pieces of f is continuous. The first piece, a linear function, is continuous at every number x. The second piece, is quadratic function, is continuous on every number x. And the third piece, a linear function, is continued at every number x. Determine what numbers, if any, the following function is continuous. So then, we're going to look at this function here and say, okay, we have determined that in each three pieces of the functions are continuous at x. We now invest continuity at 0 and 2 because that's where it changes. We begin by investigating the continuity at 0. F of 0 is 0. Because f of 0 is a real number, f of 0 is defined. Now, where it's continuous that's the good question. Where is it continuous? Here. So let's look at some other things. If we looked at plugged in, for example, Give me a second. We plug in 0 into this equation right here. We would say that this is 0 squared plus 1 is 1. So if we're graphing this function, the one function at 0 would be 0. The other function would be up here. So therefore, at 0, there's discontinuity. Now, if we look at 2, we plug in 2 here, we get 4 plus 1 is 5. 7 minus 2 is 5. Both of these equal the same thing, so that is continuous there. So the only point of discontinuity is at x equals 0. There's a discontinuity there. And that finishes off the section.